Hi everybody. Today we're going to demonstrate an easy way to do debugger patching using conditional breakpoints instead of modifying the binary. So when we want to debug binaries, a lot of times there'll be instructions that we want to modify, either go down certain paths, change values, and so forth. And the most common way to do that is through patching the binary. This is actually modifying the hex bytes so that the binary behaves differently, but that can lead to a number of problems. An alternative to do this is to use conditional breakpoints. Conditional breakpoints will do the same thing as patching the binary, but you won't have the issues. When we modify the actual binary, it's really easy to eventually mix up the patch and non-patch binary, and it will lead you to make mistakes. So when you're writing YAR rules, you'll want to make sure you're looking at the unpatched binary so you don't make YAR rules off of your patches. When you're running the debugger, you need to have the patch binary. If you share results with another researcher, you have to make sure you pass off the patch file, not have them using non-patch files, and so forth. So it's just remembering which file to use in the right time. Not that hard, but it just leads to simple mistakes that will make you look bad if you put out a report on it. So the way to solve this problem is to use conditional breakpoints. Pretty much every debugger has conditional breakpoints, and this allows you to modify the binary when the breakpoint hits in the same way that you would use to patch a binary. The difference is all the changes is in the breakpoint itself. So you're not actually modifying the opcodes. That means when you're looking through it for YAR rules, you won't see the patch binary. You'll just see the original opcodes. And if you want to save off the results, you can save it off in a script to reapply easily, to share with other researchers, or to archive for future use. So it's ultimately you do everything, plus a little bit more you can with patching, but there's really none of the downsides. So pretty much all debuggers have conditional breakpoints. We're going to demonstrate with the x64 debugger. The process will be the same in every debugger, but the syntax may vary based on different debugger. We're only going to do one just for an example. The things we typically want to patch is we want to look at function parameters. So for instance, we want to patch out sleep to have like a 0 sleep. Maybe we want to patch out a registry key, and if we're looking for like an anti-VM function. We want to patch out conditional jumps so that we force it down with a certain path. And then generally we want to look at register values. Usually when doing things like crypto, if we want to replicate the function in something like Python, sometimes it'll work for the first number of values, and then at some point it will error out, or your code won't be doing what you expect it to, and you need to debug it at the certain values. So you can actually put breakpoints on specific register values so that when you get to that value, you can debug it step by step. And that's pretty much the extra part you can do in the conditional breakpoints compared to patching the binary. So let's go ahead, now that we have that information out of the way, let's go ahead and go into an actual example. This is just a toy example I built so that we can have a couple of different situations. So if I go into this first function, and I scroll down, we can see here we have a find first file W, and we have up here this /star.star. So we're basically going to be searching all the directories looking for a target file. This would be really common in something like ransomware. And if you're doing that in ransomware, you don't want it to really search for your whole C drive and encrypt all your files, because that just causes you problems. You might encrypt the Ghidra files. It's hard to figure out what file is going to be encrypted next. So what we want to do is be able to control the environment. The easiest way to do that is to patch out this argument to find first file so that we are only looking into a directory of our choice. So in our example, we had this C drive demo folder. So I'm going to patch out the argument, which would normally be passed to C drive, to be C drive demo. So find first file does it with the first argument. So we just need to patch out the first argument. So it'll be an ESP value. So all we need to be able to do is know how to write out a string to a location. In x64, there's actually a couple undocumented string functions that you could use. And for ASCII strings, they look like they work. And if you do them in the command prompt, or not even command prompt, the command shell inside x64, it does work. But if you put them in conditional breakpoints, it will add an extra backslash. And you also can't automatically do Unicode characters in those undocumented string functions. So I'm going to show you the workaround that will work for both ASCII correctly and for wide character. And it's just a way I would recommend because it's easier to do. So first we need to create the string. In fact, let's show you the breakpoint we're going to do. So we're going to do the syntax is set, and we're going to do a brackets register, and then comma, and then we're going to do a hashtag, and then hex, we'll call it hex string, hashtag. And by putting the hex string inside of the pound symbols, it's basically telling x64 to treat them as a bytecode as opposed to a hex string. So we're going to go, first we need to make our path that we want to do, the C drive demo star.star. We need to have it as a hex string. I'm going to use CyberChef for this. You could use Python. CyberChef is just easy to demonstrate, and a lot of people are familiar with it. So I'm going to input. I'm going to do C drive / demo / star.star. And now I need to convert this to Unicode, because if we look back at our Ghidra file, we see that it's the W at the end is basically for wide character or Unicode. So what we're going to do here is we're going to do encode, and we're going to look for encode text. I'm going to double click that, and I'm going to do the drop down, and I'm going to do UTF 16-bit little endian, because we're on an Intel system, we need little endian, and then 16 bytes or bits is for the wide character. So you can see here we have the basically the dots for the nulls in between each of the ASCII characters. Last thing we need to do is do the to hex, and I'll double click that. And now we have our hex string. And this hex string, I'm going to take out the spaces by this drop down for the delimiter and do the none. So again, I could have done this in Python just as easily as doing like the string to hex and get out that way. So it depends, whatever you're comfortable with is 6 to 1 half dozen the other. So let's go ahead and copy that out and then go back to our notepad. And so let's put this out now, the format. So we're going to do set, and our x64 debugger use brackets to dereference the register. So do ESP because it's first argument, so it'll be top of the stack. And then we need to dereference it because the argument is a pointer to the string. If we just did the ESP, you might overwrite the actual pointer with the hex code as opposed to the dereferencing it. So we need comma, hashtag, paste that in. And I'm going to add a null byte in Unicode at the end, because I couldn't put that in my x64, just so it's a null terminated string. And I'm going to copy that entire command out. So now that we have the syntax that we're going to put in our breakpoints, let's go ahead and go into x64, and we'll show you how this works. So I'm going to open this up, just drag it over the shortcut icon, F9 to get in my project space, and let me look up my location. So I'm going to go to 410 Charlie 3, to Control G, 410 Charlie 3, and then I'm going to put a breakpoint, so F2. And now I need to edit this breakpoint to make it conditional, so I'll right click, do breakpoints, and edit. So what I want here is the command text, and this is where I paste whatever command I want to run. So when this breakpoint hits, it's going to execute the command text. So it's going to set the first argument, or dereferencing the value on ESP, the top of the stack, with this hex string. I'm going to set the command condition to 1, so it always runs. This break condition, you can set conditions of when you want it to break. We're going to change this actually to 0 and 1 later on. So if it's blank, it's always going to break. If we don't want it to break, we can put it to 0. We're going to first demonstrate that this works, and then we'll put the 0 so we can see that it doesn't actually stop on it. Let's go ahead and save that. And I'm going to hit F9 to hit this breakpoint. Now the top of our stack is, we can see down here in the bottom right, 19F delta 00. So in the hex dump, I'll click here, hit Control G, and go to bracket ESP bracket, and we see our string C:\, \demo, /star.star. And so that just shows us that we overwrote the first argument correctly. So we dereferenced the pointer, so it's not actually overwriting the 19F delta 00. We're dereferencing that and writing the pointer where that points to. So now we know that it works. So I'm going to right click this, do the breakpoint edit, and now this break condition, I'm going to put 0. This means it will never break, and we're just going to get it to come to that location, or just go past that location. So I'm going to put a breakpoint just on the next line, just so we can see that it doesn't stop on the find first file, but it'll stop. In fact, we'll put it a couple lines past it. We'll put on this move. That way we see it's working correctly. So I'm going to restart this. I'm going F9 to get up there, and we see we went right past the find first file up to this conditional breakpoint. Let's look in our text editor and see if I can, or the stack flow. stack view. And you see if we go up a couple bytes, because it cleaned off the stacks, this is standard colon convention, we see our string is in fact a C colon demo star. So that means we know our conditional breakpoint worked correctly. We know we didn't break on that condition, and we broke at our next site. So that's all there is to it, to overriding a conditional parameter. We can do it on this breakpoint here. Let me go ahead, right click, breakpoint, edit, and copy this argument out. So let's say this happens this first time, but let's say there was a couple functions that was going to perform this functionality. I don't want to put it on every function, so I'll take the breakpoint off here, and I'm going to hit Control G and go to find first file W, and then I'll select it, hit enter, and I can do the same thing in the library code. I select the call, hit F2, do my breakpoints, right click, edit, and in my command text, I'll paste that in, command condition put 1. And again, this time I'm going to put a breakpoint just so we can see it's no different in the library code. Hit save, and then I'll reset this. Hit F9 to get into there. We broke on it. Let's hit Control G and go to bracket, ESP bracket. And we see, again, it overrode it. And just like before, I can right click on the breakpoint, do breakpoint edit, and the break condition, I will put 0. So now that I know it's working, I'm not going to have it stop. If we put the break condition as 0 and don't put the command condition to 1, then it won't actually implement the command text. So just as a rule of thumb, I would always put the command condition 1 so that it always executes. All right, let me go ahead and reset this. So that's all there is to it for doing the function parameters. So that could be a library function or a unknown function that's statically in the code itself. So the next thing we want to talk about is the conditional jumps. So let's go back to Ghidra. And we hit Alt left to get back to where it was at. So now we see this jump at 12 alpha 9. We could either jump into exit process or we go down to this other code. So I could put a breakpoint here and modify EAX registers. I could look at the flags and modify those, but those are all complicated to figure out. Jump 0 is obviously pretty simple, but what if you had a jump above or jump greater than? Do you know which flags get changed based on those? And so instead of worrying about the flags or what the register values are, we're literally just going to change the EIP. That's the instruction pointer. So when we break here, we're at 12 alpha 9, and I want to go directly to 12 alpha bravo. So all I'm going to do is change my EIP to whatever the current EIP is, which is 12 alpha 9, plus 2 bytes, and that will get me to 12 alpha bravo. So let me go to that in x64. This is 12 alpha 9, to Control G, 40 12 alpha 9, and I'll put my breakpoint there. Just like before, right click, breakpoint, edit, and my command text. Here I can access all my registers by name. I do EIP equals EIP plus 2. My command condition, I put 1 and hit save. Again, my break condition, I'm going to leave as blank just so we can see it work. And I'm going to F9. And we see here, this might be a little bit hard to see in the screen. We skipped our breakpoint because we hit it. And we see the EIP here is actually the one instruction past the breakpoint. That's because it updated their EIP instantly. And so that's how we can tell it worked. So now we can do the same thing as the function parameters. I can right click, breakpoint. Oh, sorry, I gotta click it. And then right click, breakpoint, edit, and break condition, I'll set as 0 because I don't want to stop there. Alright, so that's how you can do conditional logic. On top of conditional logic like that, we could, let's say we had a call, let's go to Control G inside of a library call. Let's just do sleep because it's an easy one. Hit enter, enter. So let's say I wanted to patch out the sleep, but I didn't want to set the value to 0. I could literally just patch it out. So I can do this with any API. I just chose sleep because I know it's always loaded. So I could put the breakpoint on this first instruction, and we see if we change EIP here, right up to the return value, it will clean up our arguments and skip over the whole function, be the equivalent of knopping it out. So I could set EIP equal to EIP then from F0 to 00 plus 16. So I could do, let's just show you, right click, breakpoint, edit, and the command text, I could do EIP equals EIP plus And here, in this case, we would put it looks like 10 if I did my math right. And you can put them in hex values. Break condition would be 0, and command condition would be 1. If I did that, then this breakpoint would cause the to basically patch out to sleep. So I could change the argument to 0. I can patch it out. I can do this with a lot of different ways. So now it's just up to your imagination and creativity of how you do the actual patching. We hit back, get back. All right. So the last breakpoint we want to talk about is the one that you can do with conditional breakpoints, but not with patching. So this is where you get added functionality. We can see down here, we have a very simplistic kind of hashing type loop. We start a counter up at 2710 hex, and we go down to 0. And all we're doing is doing a multiply, an XOR, and EAX. So EAX would be our hashing value. So let's say we were replicating some Python code, and maybe the first 500,000 iterations working okay, and then we hit an error and our Python code wasn't matching the assembly here, and we want to figure out why. So I'm going to pretend I want to stop my ECX at maybe offset where ECX equals 2000 hex. That means I go past the first 710 hex, and then I stop it. And I've done this a lot of times on more complicated examples for crypto, where I need to watch for a specific value. So I can look at the top of the stack, doing just before the ESP. I can look at register values, anything where I'm getting a difference from what the crypto algorithm does. And then once I get to the value that I'm having error on, I can single step through it and try to see what each individual register is compared to my Python code and figure out what I'm doing wrong. So we're going to go to address 12 Charlie Bravo. And that address is Charlie Bravo right up here. I'm going to put an F2 for breakpoint. And I'm going to right click, breakpoint, edit. In this case, it's not a command text, it's a break condition. So we do ECX is equals, so double equals, and we'll put 2000. Hit save. So let me go ahead and reset this. And just like before, I'll hit F9. And we see here, it stopped momentarily if you saw that in the increment, and then went up to a breakpoint. That's because we're inside this loop going 710 hex times. And now we look at our ECX, and we see it's at 2000 hex. So now at this point, I could start single stepping through here, checking my register values and seeing why I'm not getting it right. If it's crypto, it's probably something like I'm not masking my registers out because these are four bytes, and I'm probably doing it in a Python variable, and I need to AND it with a D word of all Fs, something like that. But that's really the last type of conditional breakpoint I want to talk about. So you can see here, let's go back to the Ghidra for a second. We basically have a lot of different ways you can patch things out, and you don't have any of the problems with actually patching. So if we want to knock out entire functions, we can do that by changing the EIP, and that way we can still have the function clean up the stack, and we don't, mess up the stack. If we want to change the argument values, like in, the one we showed for find first file, we can change the top of the stack or, multiple values in the stack. Let me mention one thing with the top of the stack. If we go into, let's go to the find first file, Control G, find first file W. Let's see, I forgot to mention here. So if we do this breakpoint and, select it, right click, breakpoint and edit. So ESP brackets here, you can also do brackets plus 4, brackets plus 8. You can put the brackets and it should dereference it. If you just have a register, and I just put this for completeness in x64, if we just do ESP, it'll actually dereference that okay. But if you do, ESP, if you do something like ESP plus 4, and then it won't dereference it. So if you do ESP plus 4, we would have to do the brackets around it. But if we just have the ESP in a register, if it's a pointer, x64 will dereference it for you. So to be on the safe side, I always use brackets. You can also do, instead of brackets, we could do something like D word and read off the D word at that value. We could do byte or word, read off the different bytes, depending what it is. That's just a bit of extra information. So that's how we patch out the functions. Again, so we can do that to knock out a function, change the arguments. I've done this. Commonly, I do it with something like find first file when I'm looking at ransomware, because that way I don't encrypt my entire machine. I keep it to one directory where I have control over. I can put the right type of files in there. I know what files come in next. It's just easier to debug. I've also done it with anti-analysis files where they're looking through registries and comparing values to hash values and I know some type of anti-VM, but I don't know what. So instead of trying to step through every registry values until it hits, I can put these conditional breakpoints, and basically on the return values, I can modify the strings with the registry strings and just add a random byte there, like maybe an A or something like that. It's like the string, string plus A, or write an extra byte into it. And now my value will be different than what the registry is. So if it's looking for a specific string that's common to, say, VMware or VirtualBox, I'll have a different string in there because I added the garbage byte, and that way the anti-analysis doesn't hit. I can change paths by going modify my EIP very easily, and I can check register values or stack variables. Also, I can help find specific parts where my Python implementation isn't working. So as you can see, there's a lot of variability. You can do definitely everything you can do in patching, but it's very easy to archive this off. It helps me save it as kind of my records for my notes. So that if I look at a variant in 3 or 4 months, I can just pull up the patching, and then I can see what it is. So maybe if the variant has a slightly different addresses, I can't use the same patch files before, but I can see what I was patching out, and that helps me add it to the new file. So I would definitely recommend using this method over patching, but I just want to show it so you have the options. So I hope you enjoyed the topic today. If you did, please like the video and subscribe to my channel so you get notified when new videos come out. I also love to know what you think, so leave me comments below. If you want more reverse engineering tips, follow me on Twitter. And if you're interested in structured training, check out my website for the malware analysis classes I offer. Until next time, keep on practicing and try to learn something new every day.